I know. All right, hello. In this part of the video, we're going to do exercise 1.2 for chapter 1 lexical analysis. And the question is going to show us how to convert a regular expression into an NFA and then convert that NFA into a DFA. And then I added a bonus question where we convert that DFA into a minimal DFA. And these three questions should cover most of the core concepts for chapter 1. And yeah, without further ado, let's get started. Let's see. So the first question talks about construct an equivalent NFA using the method in section 1.3. And what this question wants from us is to convert this regular expression that we were given, which is the same as this one. Yes, it is. Um, and we convert it into an NFA. The way we do that, the method mentioned in 1.3 is to take this regular expression and break it apart into smaller expressions and convert each expression into an NFA or an NFA fragment. And the way it does that is by making use of this table over here. It's a very useful table. It shows you if you have like a single element, you'll have like a DFN incoming arrow into a state. It's blank, but you can name these states whatever you want. And then the value on the arrows, you can have it will be this value over here. If it's like this, if you're reading an expression, if it's an epsilon, then what the value on the arrow will be an epsilon. If you have two values following each other, then you'll have whatever the content is here, following whatever the content is there. And then if it's an S or T, it'll break apart into this fragment over here. And if it's an S star, it's gonna it's gonna be like a state. We're gonna go into a state, then we're gonna follow an epsilon into S, and then we're gonna come out from S into this. And the reason they're shaped like ellipses over here instead of like the regular circles is because this S star could also be in the form of let's see, A, A, and B star. So it could also be in this form. So that means when we like come out over here, we're gonna have the A or B. And since we have A or B, this can further be broken down into this, and then it just expands like that. So that's the idea here with this. You can read through the book for more details. Yeah, I'll just take you through this one example first, and then you can go to the book if it does not make any sense. And so we're gonna do this regular expression here, and we're gonna break this part into its own smaller expression first, and then we're gonna do this part second, and then we're gonna do this part third, and then we're gonna combine them all together. So let me see, what color would this? I think blue. So let's start with A. So for this, for entering this, I already created like some sample elements for me to copy. Um, Making use of dashed lines to represent a state that is an except state, because I don't want to do two circles. This is a very good website for whiteboards, but I don't think it handles double circles well, unless I'm missing something. Yeah. Just circle. That's just me deviating a bit. Okay, yeah, it does not have double circles. I'll just fast forward that bit. So I'm just gonna copy this, and we're gonna convert uh, this part first. All right. So the way A star is going to look, just see, no, I'm just gonna take A star. I'm just gonna put it over here. So A star, as we see over here, it's going to be an arrow coming in and then an epsilon coming out, and then it's going to go in. And let's see. So over here, we can name this anything we want. I'm going to name this first one 0. Now, numbers are very good to use because you don't know how many states you're going to have. since it's the first, like since A was the first expression, this is gonna be our start state. Then I'm just gonna add an arrow over here. It's coming in. We represent the start state. It looks good. And then we're going to come out. So, now, since this is an A star, it's going to, let's see, it's going to have a value, and it's going to go into S, and then it's going to go into this. This is going to be an epsilon, and then over here it's going to be another epsilon. So what is S? So S, it's just A on its own, and we know that A on its own is this, right? So let me just do this. So A, since A is like so, and it has a value coming out, what is this arrow going to be? It's going to be this epsilon over here. At least, yeah, this epsilon, and this epsilon comes from here. See, so I'm just gonna do this. Just gonna be fancy with it. I want the arrow to be circly. Okay, and I don't have a character for epsilon. Ooh, that's a big. Let me just get that real quick. Okay, I finally found my epsilon. There you go. So I got my epsilon over here, and it's gonna go into A, since A is one character over here. And then we're gonna go, since there's like nothing else, it's gonna go back in. And what value, so if we're gonna go back in, what value will this be, right? Wait, I made a mistake. No, 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 no. This is gonna be the name of the state, and then the letter A is gonna be this. Because if you look at this, it's gonna come in, then we can name this whatever we want, and then it comes out as A, and which is what happened over here. And then it's gonna come out as epsilon again. I'm just gonna paste epsilon in here. Let me just paste epsilon over there so that I know that I don't have a fancy keyboard that has a dedicated epsilon button. But yeah, and since this is a state, we're gonna name it 1. Right? So okay, now we're on track. So we got this. So this whole part represents just circle it faintly like so. So this whole part represents A, like A star, and I'm just gonna change the color to red so that you know. So this whole part comes from A. So if you were to convert this to that, no. And now, where's this gonna go to? Uh, this is gonna go to A or B. I'm gonna paste this over here. A or B. So just, and then we'll do this last. So now we're gonna have A or B, and how does this look like? So if it's like S or T, we're gonna come in, and then it's gonna take an epsilon to here and an epsilon to there, and then it's gonna take whatever values. And so we're gonna have two states. So we're gonna have this state, and we're gonna have that state, and everything in between, right? So let me just copy this. So this will be our second state, right? And then we're just gonna have everything that's in between over here. So eventually we're going to have, let me see, where's my pen? There you go. So we're gonna have whatever and whatever. This is gonna be epsilon, this is gonna be epsilon, and it's gonna connect to this, like so. And the values that come out depend on what's in here as well. And yeah, and then this is gonna go out into something else as well. So we'll take care of that later. All right, so um, let's do the first one. So we're gonna do, I'm just gonna take out this. We're gonna name this state 3, and we're gonna name this state 4. And this is gonna be, I want it to be circly. There you go. And it should be automatic here. Nice. So there's some nice piece of programming here, won't lie. So I'm just gonna copy. Is it still my clipboard? I doubt. Yeah. Yeah. Just copy this, paste, and paste. So we have this state over here and this state over here. And since A is just one thing, we're just gonna do the exact same thing where since this is just A and then this is gonna be B, we're gonna have it be like so. Okay, A, and then this is gonna be B. All right, because since to translate, if you look at S, in this case, our S is just going to be A, and A, when we translate it, it's going to follow this pattern over here. And when we translate B, B is going to follow the same pattern where something goes in and then B comes out. And then here you go. And that's how you get the green bit. Just copy this. Hopefully this is making some sense. If it's not, you can rewatch the video just to make sure that it's like actually clicking. Um, oh, here's the do watch again. Hopefully I do the YouTube thing where I'm like, here's a regular expression video because understanding regular expression will help. All right, so this is it just keeps going, and we're just gonna press this. So now, what comes out of here? So since it's going to be an epsilon, so we're just going to put another epsilon over here. And we're going to name this one 1, 2, 3, 5. So this is going to be state 5. And how does this work? So state 5 is followed by this, right? And remember that since these are concatenated, so we're going to have S followed by S, and these are S will be the smaller fragment and T will also be the smaller fragment. So I'm just gonna make it go down like this. So since we're gonna look at A, since it's gonna break up twice, so it's gonna be like so, right? Something missing. Okay, so yeah, 5. So this is epsilon, which comes from here, and the first thing we do is that we take we're going to convert this A into this fragment. So it's going to look like this. Okay, I'm running out of space again. And then we're going to connect. So okay, now this A was this, and now we're gonna convert this A into this part. At least it will translate into that. So now we're gonna have this 6, and then we're gonna have 7, right? So normally that you'd have something like, okay, where would this go? At the moment, we don't, since it's the last like expression, we don't have to move any forward. And since it's the last expression, that means the regular expression is valid in this case. So we're gonna do the double dashes over here. At least not the dashes to signify that this is the final state, and also just get this as well. I thought if it converted into blue, I would have, my mind would have been blown. And let's see, convert this into blue. So yeah, now that's how we converted this regular expression here into an NFA. And this is an NFA because it has epsilon transitions, of course, and it's non-deterministic, but that's how you do it using the fragment method. If this did not make any sense, uh, that's okay. You can go find any method that works for you, um, as long as you're able, because there are multiple ways to write the same um, minimal there are multiple ways to convert a regular expression to an NFA, and a regular expression can have many different NFA. So this isn't the only correct way to do it. There are multiple other ways that you can do it. So you can look for a method that works. This is how Tobin's textbook explains it by using fragments, and your final answer would look like this. Let's just remove the borders and then put these together again. And yeah, this will be your final answer for A. Again, remember this is the except state, not. I would try to do the two circles, but that would not It would not be feasible to copy all the time the amount of space that would be needed. Okay, maybe that works, I guess. Maybe I should have done that. Well, anywho, let's move on to the second question. If this doesn't make sense, please ask in the comment section. Hopefully, you guys can like help each other out. Yeah. Now, next question. Convert NFA, convert this NFA to a DFA using algorithm 1.3. So I've got some good news and some bad news for this question. The bad news is that this is the algorithm that you have to use to solve this. And it looks like this. You can find it in the textbook. I think it's well explained, but your final answer would look like this over here. At least the answer, once you convert it, would look like this. I don't like to do it this way. Yeah, this is if you prefer to use this algorithm, this is the answer you will get. And if you're wondering where I got this screenshot from, on Torben's website, there's a solutions manual. I'll put the link in the description where to find his website, where you can find the solutions thing. Um, but this follow this algorithm in the textbook or go through it and you'll get this. But I prefer to use my own method for converting an NFA to a DFA. It's not like a patent method. I learned this in a theoretical computer science, automata theory. If you're from the same university as I am, then you know which um, class we learned this from. And it's actually, I prefer using this method where we use e-closures. Okay, even this method uses e-closures, but I prefer to use a table, a transition table to convert the NFA into, oh, I can actually raise the font. Okay, there you go. It's pretty cool. I didn't know. I thought, how am I gonna zoom in? So the way the method works is just making a transition table, then use the transition table to make the DFA. So we convert the NFA into a transition table, and once we have our transition table, we use that to draw our DFA. And yeah, I prefer this method for two reasons. One is because I feel like it's straightforward. I have not tried the other method, but this one seems straightforward to me. And second, it is useful for SLR in chapter 2 when you're working with that parser, because if you that parser would require you to convert the grammar into an NFA and from an NFA into a transition table. So it's better to learn it early. So you can follow along with me, but for those of you who prefer to follow the textbook and do this method, uh, I won't be covering it, but you can follow it. And here's the final solution if you do it. So let's do this. Okay, that was a tangent. But hey, let's get started. So the way the table method works, at least the transition table, um, you're gonna have a table. First, you're gonna have the first column is not necessary, but it's pretty nice to have, is a name column, and this will be the name of the state. Just to give a quick explanation of how converting an NFA to a DFA works, is that um, you're gonna be grouping a lot of these states. Oh, I realized that 0, 1, 1. I realized that. Let's see. Let's just call this 0, 1, 2, 3, 4, 5, and then 6, and then 7, and then 8. Sorry about that. I didn't, luckily I caught that. So the way converting an NFA to a DFA works is that, at least we're using this method, is that we group similar states together. So we group a bunch of states by using the method called e-closure. And once we group those, we can turn this non-deterministic automata, finite automata, into a deterministic finite automata, where each state has only one possible transition to make. essentially. So we're gonna be grouping this with this with this with, and so each one would make up a bunch of states, and then they just transition from that. So the main idea that you have to take away is that we are grouping. And how do we do this grouping? So the first thing is that we're gonna have the table. We're gonna have the name column, which is going to be the name of the group, or the group that of states that we've just made, and then X, which represents the states. I'm just gonna call this. Also represents. Uh, let's see, also represents the states as well, which is one or more states that we're going to at least apply e-closure on. And e-closure is a I don't know a formal definition, but it's a function that will allow us to group um, states together. And then we have A and B, which are the terminals or the transition values. So uh, yeah, that's it. So let's apply e-closure. So the way I like to do it is that when we apply e-closure, we ask ourselves, where can we go from this state? So the first state we always start, the first set of states that we start off is just the start state over here. So state zero is the start state. And so it's gonna be the first one in the set. And in this set of states, we ask ourselves, where can we go from state zero to which other states can we go to from state zero by doing nothing, right? Uh, not sure if that's a good, for me, it works. So we can go from state zero to state zero. So when I say doing nothing, I mean by transitioning, by either by transitioning using an epsilon, and epsilon means nothing. We can go from state zero to state zero by doing nothing. And we can go from state zero to state one by doing nothing because we're following this epsilon over here. So we can go from 0 to 1. See, how did that happen? We can go from state 0 to state 2 by doing nothing or by following epsilon. And we can go from state 2 to state 3 and state 4 by doing nothing or following epsilon. So it's going to be 3 and 4. And that's where it ends. So the way it works is that we start off with 0, and then let me use a different color. Start off with 0, and then we jump to here following the epsilon. So we include the 1, and then we jump over here, and then we include state 2. Then we go over here, state 3. From 3, there's no other epsilon transitions. So we go to state 4. 4, there's no other epsilon transition. So it's going to be 0, 1, 2, 3, 4. And that is how you find, that's how we know we're done. That's how we find the e-closure of a given set. And then over here, that will make up our first row over here. And this is our first group of states. Hopefully you're following along. And now we ask ourselves, from 0, 1, 2, 3, at least from these states, which one have a transition, which states have a transition with A, right? Like, so we're gonna look at the states and we're gonna look for the states that have a transition with A. State 1 has this transition with A over here. So if we follow A, it takes us to 0. And state 3, if we follow A, it takes us to 5, right? So from this set, we're going to add a new row. At least we're going to add a new row. We can go from state 1 to state 0. So we're going to add 0 over here. And now we can go from state 3 to state 5. So we can go to 5 over here. And now that I don't think from these states, we can go anywhere else. Yeah, so from 3 to 5 and from 1 to 0. We have this, and we're going to name it B. So we're going to name this group B, and we're going to say this state will take us to group B. And hopefully that makes sense. So we're going to do it again, but this time with B transition. So from which states can we transition using B? So we have 4, and I don't think we have anything else that can do. So 4 takes us to 5. And yeah, so takes us to 5. So just 5. Since we don't have like a set that just has 5, we're gonna create a new group for this. So one thing I forgot to mention is that this stays unique. So if we happen to like make a set that matches something that already exists, we just go to that state. So we're just gonna name this C, and then this is just gonna be C. And when I look again, just to confirm, yeah, we don't have any transitions for B. So yeah, that's our first table done. And now we have two, that's our first row done, I mean, and now we have 2 extra rows, and we're gonna keep doing this until we run out of rows, essentially. Let's see. I'm just gonna have a sip of tea. That's good. Okay, from B, we do the same thing. So B has 0 and 5. It has this group X. And we have to populate this row, which is the E closure. And the E closure follows the exact same concept. And since this set over here has 0 in it, we know that we know that 0 can take us to here, here, and here, and here. So all the values, since it has 0 and we already did that calculation, we know that it's going to have 0 itself, 1, 2, 3, and 4. And now it also has 5. So where will 5 take us? Oh boy. Okay. Hopefully the eraser. Okay. So I'm just gonna erase this. Nice. Um, where can 5 take us? 5 by following epsilon, it can take us to itself. So 5. So where can we transition to or go to by doing nothing? To 5 itself, and we can go to 6 as well. And since this is a dead end, we cannot go anywhere else to do. So that means our set over here is going to have 5 and 6. And that's the end of it. So this is our new grouping over here. And yeah, and we just followed the same logic, the same reasoning, at least the same questioning. We ask ourselves, where can we transition from this set of states? Where can we transition to using A? Let's see. We can transition to, so using A, so we have 0, 1, 2, 3, 4, 5, 6. So using A, how is the pen tool? What's the pen? Okay, here. We can go to, from 1, we can go from 1 to 0. And what else? We can go from 3 to 5. Mm-hmm. And since we have 6 in the set, we can go from 6 to 7, right? And this is a new like set of numbers here. And yeah. So from here, since we don't have 0, 5, 7 over here, that means we have to add a new row. So a new row, we're gonna call this row D, or just D, there we go. And it's gonna be 0, 5, 7. 0, 5, 7, since this is unique. And we're gonna say this takes us to group D or state D. And again, we do the exact same questioning. So from this set of states over here, where can we transition to using B? I should have given this a different color. No, it's just my ADHD. I don't have ADHD really. Or do I? I don't know. I'm just gonna erase this. Okay. So from this set of states over here, where can we go with a transition of B? Again, so since it's 0 to 6, it's just 4. From 4, we can go to 5. And where else? And nowhere else. So since it's just 5, we don't have to add a new row because we already have a 5 over here. Since it's like, again, we have to keep things unique. So we don't have to add another row that has 5 in it. We can just keep it like so. So in that case, we're just going to do what? we're just gonna say from this set of states, where can we go using transition of B, go to C, and here we are. And that's it. And then we just move on to the next row. So we just follow along the same, at least type of like reasoning. Um, let's see, how do we solve this? Okay, I need an eraser. I need to memorize. I thought it was E. I thought it's okay. Okay, there you go. Man. So now we have to, what do we have to do? We have to, what did I do? Oh, did this come? Oh, yeah, that's why I clicked E, hoping to find, hoping for the eraser to show up. So I should P for pen. All right, from 5, where can we go by following nothing? So we have to find the enclosure of 5. From 5 itself and 6. And that's where we have to go. So over here, it's just going to be 5 and 6. Simple. There you go. And then from 5 to 6, we ask ourselves the same thing. Where can we transition to with A? 5 has nothing to contribute, literally. And 6 takes us to 7. Uh, takes us to 7. Let me erase these two. There you go. So 6 takes us to 7. So that means we're going to have to add a new row where we just have 7. And this one is just going to be called E. I keep 7. There we go. Lovely stuff. Uh, yeah. I feel like I'm missing something. Yeah, the whole reason we're doing this. So we just put in E, and do we have anything? 5. When from this state, where can we go by following transition B? 5 has nothing to contribute, and 6 can only transition with A. But we don't have a B. So for this, you can just leave it empty. Oh, you can just, I forgot there was a whole symbol. I think it's I'm not sure. I think it's this symbol over here. You can leave it empty, or you can just write no, this is too thick. I got to now you can just write this symbol over here. Yeah, just to show that there's nothing. I won't be doing that. I'll just be leaving it empty. You can do that too. Just leave it empty. And yeah, so that is it. That is it. And now we have this set over here to deal with. And what do we do with this? We've just followed the same reasoning. Let's see. So we have 0. Since we have 0, we don't have to recalculate the wheel again. We know that it's gonna have 0, 1, 2, 3, 4. And since we already have, we know we have 5, we know where 5 is gonna take us, 5 and 6. And we have 7. So this was just finding the e-closure. So we already did the e-closures for others, and now we have 7, an e-closure we haven't done. So 7 doesn't have any e like epsilon transition, so it just takes us to itself. So 7 is the only one, so it's gonna be just 7. Oh yeah. So this set has almost all the states. And now what do we do from here? Then we just ask ourselves the same question. Yes, the same question. So from 0, 1, 2, 3, 4, 5, 6, 7. That's a lot. Hopefully I didn't make a mistake along the line. um, from here, I'll say the same question. Where can we transition from this set of states over here? Where can we transition to with A? Where can we go? Let me just get the pen. So we can go from 1 to 0, which takes us here. We can go from 3 to 5, which takes us here. Since we have 6, we can go from 6 to 7. Since we have 7, we can go from 7 to 8. And yeah, to double check, yeah, that's the whole shebang. So we have 0, 5, 7, 8. So now we just add 0, 5, 7, 8. We're going to call this F. And it's going to have a 0, 5, 7, 8. Wham, bam, thank you, ma'am. And then we're just going to call this F. And yeah, I think we're done with this. Now we have to do ourselves. Where can we go with a transition of B from this? Get the eraser. Let's do it again. Erase, erase, erase. And let's see. So we can go from 4 to 5, which is B. And wow, there's literally nowhere else. Why am I surprised? Why am I genuinely surprised? Okay, yeah, it's just that. It's B. Okay. What do we do here? I guess we just say since we already know, since we already have C over here, I'm gonna put C, and that's it. Yeah, that's it. I was expecting a lot more. Okay, so from 7, this one, e-closure of 7, we do the e-closure of 7, and it's just gonna be 7. And yeah, and from here, where can we go? We can go from 7 to 8. So for this, we're gonna have add a new rough, where it's just gonna be 8. And this one, A, B, C, D, E, F, G. So, yep. I have 2 degrees, by the way, and I still have to do my ABCs like that. So let's see. 7, 7. Okay, so 7 takes us to G, and it does not take us anywhere else. So we're just going to leave this empty. So now we have 0, 5, 7, 8. So we already know 0, 5, 7, 8 already has all of this. So we're just gonna like save ourselves some time. And 8 takes us nowhere. Just takes us to 8 itself. Like that's the e-closure of 8. It's just gonna be 8. And then yeah, I'm just gonna erase this. There you go. So now let's ask yourselves the same question. So from here, where can we transition to A? And where that will take us will be, let's see, 0, 1, 2, 3, 4, 5. So with the transition of A, this will take us to, so from A, this will take us to here, and this will take us to, yeah, but this will take us to here, 3 to 5 here, 6 to 7 here, and 7 to 8 here. So it will take us to 0, 5, 7, 8. And yeah, 8 does not really add anything. So this is going to take us 0, 5, 7, 8 is this one. So it's just going to go to group F. And we ask ourselves the same thing. Where can 0 from this set, where can it take us? And surprise, surprise, it will just take us from 4 to 5. C. There you go. And from 8, we do an e-closure of 8, and we just get 8. And where it can take us? Nowhere. And there you go. I think we're done. That's it. It took a minute. It took a minute, but we're done. We've converted this NFA into convert into a transition table, a DFA transition table. And now let's convert this DFA in this NFA, this transition table into a DFA. And before we start, so one thing to notice is that if each group here represents a state, so this is each one of these is a state of its own. The way it's going to work, okay, now let's just make the states first, and then we'll add the final accepting states at the end. So I'm just gonna copy this, and let's just call it A. And then A takes us to B, and A takes us to B when we read A, and A when we read B takes us to C. There you go. And also since A is the okay, no, let's do it now. Let's do it now. Since A is the first one, is the element that has the like the start state. A is gonna be the start state. So the first row is usually the start state as long as it has a start state like 0 on its own over here. I don't know the exact logistics, but yeah, yeah. So it's just gonna be like this. So this will be our start state. And now let's see. When okay, when B reads A, uh, we get D. But when B reads B, we're gonna get sorry, when B reads B, we're gonna get C. And then when C reads A, it takes us to E. So this one reads A. Okay, cool. Okay, now you know where my if you like the voice and you know it's Dell. Let's see. Where was I? Oh my God, if the mic is off from here on, I am not re-recording this. Let's see. F. Okay. Wait, okay, from E we go to oh yeah, we have to do D first. Okay, so how do we go? Yeah, yeah. So D takes us to F. I'm just gonna put F here. Let me look where you read something. Yeah, because I'm wondering where would be the best placement for F. So I think down here would be better. So F when we read A. And then for this one over here, uh, yeah, I'm just gonna put it like so. Hopefully nobody's too crazy about like the way the shapes look. All right. Looks like a kidney. Let's see. So this is when we read D to C, B. And then E. E takes us to G. Okay, is it? Okay, I'm just gonna put G over here. When we read A, just give it more room. There you go. And F goes to F. F goes to F when we read A, and then yeah, because we all see it coming. And then F. I'll just move this down over here. Yeah, just give us more space. All right, then F. F. Okay. F takes us to F when we read A. All right. And now it looks like a comma. Okay, I think that is it. We did everything. And now we've done this. We're left with one thing, the except states. So how do we know if something's an except state? So when we look at our previous diagram, our NFA, and this over here is our except state, meaning that it signifies us being done. So in our case, since we're doing groupings, whichever group contains an accept state will itself be an accept state. So which groups would that be? This group is an accept state, and this group is accept because they contain 8. I'm looking at the wrong thing here. Look at the E closures. So this has an accept state, and this has an accept state, right? So yeah, if any set contains an accept state, then it itself is an accept state. So in this case, it's F and G, and to signify that, we just do this, convert this into that, and convert this into that. And now we have a complete diagram. I think it's correct. I'll have to double check here. I'll double check later. Oh yeah, that's the main idea. So that is how you convert an NFA to a DFA using this method over here. You can also use D as well. I'm pretty sure it's the exact same concept, but your groups, uh, everything is a lot clearer. It's the same thing. All these methods are the same. Just I prefer this one. It's a lot more visual. It's also good practice for the future as well. So now that we've done this DFA over here, it's a DFA because there are no E closures and it's not non-deterministic, meaning that like if we're on E and we want to go A or B, well, there's one transition for A or B as well. And I don't think there's like everything is good here, at least since this one is very deterministic as well. Now let's move on to minimal DFA. And a minimal DFA is a DFA that has the least amount of states for a given language or so, um, or for a given regular expression online. And it there's an algorithm to making this. It's very simple. It follows the same idea of grouping. So just how we grouped these states. Also, by the way, just as like a side note, see how we named this? Another valid thing that you could have done is like instead of writing A, you could have just written this as well. Uh, this is also valid instead of like writing A, B, C, D. Like this is just for the reason we have this name column is just for that reason and no other reason at all. But yeah, thank you. Uh, Now that we've grouped, so that's just to show that these dates were grouped into these as well. So it makes it easier. And now we just apply the same concept when converting a DFA into a minimal DFA. And to do that, we split them up into groups. And we split them up into the least, like the lowest number of groups possible, which is usually one or two. And we try to build transitions between them. Uh, as we go on, you'll notice that the groups will break apart, but we'll start from the lowest and hopefully things work out. I'm better at at explaining while doing instead of like talking. So we're gonna start off by splitting up into the two smallest groups possible. So this will be the just start by grouping the accept states first. So this will be our first groups. This will be our G1. Uh, G1 is just the naming convention. So the naming convention you'll see is just GN, where N is the nth group, but you can name it anything. You could name it Steve if you want, really. It doesn't really matter. So now we'll just name it G1. Mm. And then this group over here, it will be G2. So we're grouping final accept states and normal states as well. And we'll try to check for consistency. I'll tell you what I mean by consistency. But this is the first way, like the first step to answering, at least to converting a DFA to minimal DFA, is where you split these up into groups as well. So let me just take this out. And let me just copy this. Gonna need it over here. Put it, yeah, on the right hand side. Much better. So when we split them up into groups, our first group over here will be F and G. And then this will be all the other states. So A, B, D, C, and E. For all you OCD people, here you go. I'm just gonna move this a bit closer. So the first thing is that we're good for each group that we create, we're gonna check for consistency. Like, does one group do the transitions match for each element in the group or for each state in the group? You'll see what I mean. So this group G1, it has its own table, G1, and the table is the group name over here. This is just the group name. Doesn't really matter, just the first column. Then followed by A and B. A and B, these columns will be for the non-terminals, and each group will have its own table. Non-terminals, I mean the terminals. So we're gonna say, so for group one, we're gonna have F. So we're gonna do the same thing here. We just raise the font. Gonna do this as well. Can we raise the font? I don't know. Let's just raise the font for everybody. There you go. Much better. I'm just gonna delete this one and then copy. Yeah, if I knew we could do this, I would have done it way long ago. So this one is gonna have F, and then we're gonna add another row for G. There you go. And then we're gonna have a group for this one as well. So it's gonna be A, it's gonna be B, it's gonna be C, it's gonna be D, and it's gonna be E. So now we're gonna see for here, we're gonna see when in this group, when we transition using A, what group does it take us in, right? So F, when we transition from F using A, where does it take us? It takes us to itself. So it takes us to an element that is in group one. Yeah, are you with me? So here we're just gonna put in which groups we transitions to, right? And then what if we follow B? Something's wrong here. Oh yeah. I thought, okay, that makes sense. Does it? Wait a minute. Huh? Huh? Did we make a whoopsie daisy? So F. Okay. B. Fixed it over there. So okay. How did I miss that? Cool. Sorry about that again. Luckily we caught it while it was time. I double check. Okay, I'll just put a note. Let me just write that down. Uh, all right, I wrote that down so that I won't forget. All right, let's see. So now we have FG. Don't worry, I fixed the mistake with B. So when we follow G, it takes us to itself. And then when we follow B, it takes us to C, which is an element in G2. All right, now we're gonna look at G. Where does G take us? G, when we follow A, it does not take us anywhere. So we're going to put a dash. And when we follow B, it does not take us anywhere. So it doesn't transition anywhere. And you'll notice that these two take us to different places. So they're not consistent. So in this case, what we do is that we're going to take this group and we're going to break it apart into, like, we're gonna break it apart. So the ones that take the rows that have the same like values will be in their own separate group in this one. So in this case, it's only this one, and then and F will be in its own group as well. So this is gonna break apart into, so this is going to be in G3, and then this is gonna break apart into G4. All right, so let's do that. Okay, copy. So this is G4, and then it's gonna be G3. Okay, and we just have to. How do I? Hmm. There you go. All right. So now we've broken these into their own separate groups. Oh yeah. And now everything is consistent. So this one, it's a single row. So all the rows in this table are consistent. And here it's a single row. So all the rows in this table are consistent. So we'll keep it like this. So if you're not following, you will eventually. Let's keep doing it then. Yeah. So let's see. Let's see. So now we have A, and A. When we follow A, it takes us to B, and B is in group 2. And when we follow B, it takes us to C, and C is in group 2. And for B, when we follow B, takes us to D, which is in group 2. And then when we follow A, it takes us to C, which is in group 2. So when we're in C and we follow A, it takes us to E, which is in group 2. And when we're in C, it takes us to D. When we follow B, it takes us to D, which is also in group 2. Let me double check if that one matches, just to be on the safe side. No. Oh, no, 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 it's the other way around. It's the other way around. So they're very confusing. Very confused. So it takes us nowhere. It takes us nowhere. Luckily, I checked. I should have split these much betterly. Yeah, I should have made that. Yeah, that makes sense. There you go. All right. So now we have D. Where does D take us? So D takes us to C, which is in group 2, and A takes us to F, which is in group 3, and E takes us to G, which is in group 3. Group 3. And this takes us nowhere. All right. Now we have a lot more variety to deal with here. So now that you notice that this is not consistent, like there are rows that have different values, only some of them do. So what we're going to do in this case is that we're going to group the rows that have the same value. For instance, this row over here. Okay, does it make sense? So I'm just gonna use the pen, I guess. But this row, we're gonna put it in group G5 because they have the same value. And this one will be in its own group, G6. And then this one is going to be in its own group, G7. And this one's going to be in its own group, G8. All right. So we group the rows that have the same value. And so we break up this group into these smaller groups, to which we get, just going to copy this. I'm going to turn this, I don't know what this is over here. All right. So we're gonna have G6, and then we're gonna have G7, then we're gonna have G8. And then here we're gonna have so it's just gonna have C, and C is taking us to G2. Since G2 does not exist, we're just going to leave it blank. And this one is blank as well. And blank, and blank, and blank, and blank. And since G2 does not exist, we're going to have to change this one as well. And we're going to have to change this one as well. So we're going to have to redo this whole thing. But it's okay. It's okay. And then, yeah. I think it's everything. So now we just delete um, this group. Uh, delete. Okay, so now, there we go. So yeah, I think that's everything. A, B, C. I forgot to put in the thing. D, E. All right, so I have A, B, C, D. Okay, now I have to delete these again. There you go. Undate. And then this will be our G5. You can keep the original group names, but it's better to change them, in my opinion. So now these are going to be empty. So we're going to have to redo this whole thing. Hopefully it all stays consistent. So for G, so let's start with G5, since it's right here. So G5, no, let's just do G3. No, let's do G5. Sure. I'm very indecisive. It doesn't really matter which one you do, but the idea still stays the same, where every row has to be consistent. So here, A will take us to B, which is in G5, and B will take us to C, which is in G6, and B will take us to D, which is in G7. So we already see like we're gonna to split this group apart, and then we're gonna have see B takes us to B takes us to see, B takes us to C, which is in G6. All right, not consistent. So these rows are not consistent, not consistent. So we have to break this apart even further. So weird, right? So it just so happens that we have the minimal, I guess. So we're just gonna make this into so this is gonna be G9, and then we're gonna have G10, and G10 is just gonna have A. Just gonna have B. So, and then over here we just erase, erase, and then remove. Okay, what can I delete? Delete. All right. So each group has only one element, so these groups are pretty consistent, but that's pretty much the whole idea. We just so happen, I don't know, I guess the DFA that we made was the minimal DFA after all, you know. Let's see. So let's start with, yeah, it's all the same really. It doesn't matter which one we start with because it's all pretty consistent. Let's start with A. So A takes us to B, which is in G10. And then B takes us to C, which is in G6. And then F takes us to F, which is in G3. And here it's blank. And then G4 is in G4 is in so G takes us to, it takes us nowhere really. Oh, okay. So let's see. And then G6, C, when we read A, it takes us to just E, and E is in group G8. So, and B, nowhere, so it takes us nowhere. Now we have G7, which has D. D takes us where? To B, and B is C, so this is going to be G6. And then this is going to be let's see, so D. Okay, oh no, B takes us to F. D takes us to F. What's F? It's G3 over here. All right, I misread that. And then the B takes us to C, which is G3. I messed up again. I got G. So yeah, and then G8 has E, and E, when we read A, takes us to G, and then G is in G10. That's G4, G4, and here is nothing. And B, A takes us to D. D is in G7, and DB takes us to D, so it's G6. So all of these should be different. They are all different as far as I tell. So now that we have the different groups, we just turn each group into its own. So each group is a state, and we just like turn these into a state. And yeah, let's do that. So you just follow the group. We're gonna get the same diagram, but um, just so you just copy the one with the G. I cannot just. So you're gonna end up with the same diagram, and it's the same idea. Whichever group has the accept state is also itself an accept state, so it's that same concept. And yeah, and see, and whichever group has the start state is the initial state will also be an initial state. But yeah, let's do that. So G3. Okay, why am I making life difficult? Let's have it side by side. Uh, I don't want to reinvent the wheel. So D over here. What do we do? What do we do? So let's start with G3. So which one has A? It's G9. Just so like we start simple. So I'll start with G9, and just gonna give it the arrow treatment. There you go. So that's our start state. And then G9. Yeah. So now the G9 will take us to G10. So all of these are, if there are more rows, if they're like we had more rows, they'd all have the same value. They'd all have the same value. So I'm just gonna use this to know where to go. So this one would also be G10 if there are more values. So you can practice this with other these more complicated sets. I guess I must have chosen a simpler one. I suppose pretty disappointing, but them's the breaks. So G10. So this will take us to G10 when we read A, when we read A, or A. And this will take us to G6. So this will take us to G6. When we read B. And let's see, G6. Let's see, where will G6 take us? Okay, now we've done G9. What's G6? So G6 will take us to G8. So we're just going to write G8, and when we read A, right? Yeah, we're done with this. We just put it on the side. G10. G10 will take us to G7. So G7, when we read A, now this will take us to I want it to be, yeah, good enough. What? No. Oh yeah. G10 will take us to G6. Whoopsie daisy. So this will take us to B. Yeah, using B. We're done with this. Now what are we left with? Let's do G7. So G7 will take us to G3. G3 using A, and then we'll take us to, yeah, we're gonna, yep. Yeah, I'm just gonna put like this so that we don't make the same mistake. It now looks like a heart. Okay, just G7, and we read A using B. Okay, put G7. Now we have G4. Okay, we don't have G4 yet. G3. G3 takes us to G3. Now we read A. And then we have G8, which takes us to G4. And G4 goes nowhere. All right. Looks a tad different than last time. And then let's see which ones are accept states. So F and G. So which group has F and G? F and G. So G3 and G4 are accept states. Like that. And right here. And there you go. That is the minimal DFA. Hopefully this helps. If it was a different like set, maybe he'll get a different like DFA. But yeah, that's like the minimal DFA. Then you can have multiple different DFAs for the same like thing, but this uh, just so happened to be the minimal. Hopefully that was helpful. You can go through. You can watch the video again if you don't get if you don't get how something works, or you can yeah, ask for help in the comment section. You can leave a like too, please, and subscribe. Mm, that too. At least it will encourage me, and not because I want that sweet revenue. Anywho, thank you very much. I'll catch you later.